Okay, let's get into the problem. What is acceleration? Means it's asking acceleration due to gravity means nothing but the gravitational field strength. If you're getting confusion, gravitational field strength. What is the gravitational field strength at a height r? Straight away, get into the basic concept. What is the gravitational field strength at a height r? Don't go for the formula at a depth r minus h, that one. You look at the r. R is when you can use that formula, like a g dash equal to g1 minus h by r. Tell me when you can use this formula. When h is very small, but is not asking something h very small. Look at that one r equal to radius of the planet. So definitely this is not applicable. Able to understand all of you? Please do. You should use your basic mathematical skills. This is applicable only when h very much less than r. What is the height given? The height is given h equal to r. So no longer this is applicable, no? So this formula is applicable. So forget this, leave this one. But sir is asking acceleration due to gravity. The gravitational field strength is nothing but acceleration due to gravity. Okay, now we'll calculate the first, what is the mass of these spheres. First we'll calculate the mass of this one. And what is the mass of this? M1. Mass of this be M2. I think this will help us a lot. What is the mass M1? M1 should be equal to density rho naught 4 by 3 pi r by 2 whole cube. This will be pi r cube rho naught. This will be 6. Similarly, what is M2? Mass of this layer. This should be equal to M2 should be equal to density rho 4 by 3 pi r cube minus r by 2 whole cube. Why it should be like this? Because the mass present in this region, r minus r by 2. What is the radius of shift? So what you should do in this particular region, in a sphere of radius r, you should subtract this much of volume. Then you get this particular volume. Is it okay now? Volume of this part. Eight. This will be 7. Rho into. Okay, this will be. Let me write this one. 7 pi r cube rho by 6. Check it once. I think I'm ending up with this much of answer. And now we know M2. How to calculate the field strength there? Applying Gauss law, you draw a Gaussian surface. Then where do this both M2 and M1 will appear like a point mass kept at the center. So what is the field strength at point 1? This should be equal to G M1 M2 by total. This will be how much? R plus H whole square. What is H? H equal to R. Then you'll get the field strength at 1. Can you do calculation? I'll just give all the basic ideas where H is equal to R. Substitute that, you'll get the field strength at 1. And this is nothing but acceleration due to gravity at a height R. Then again it's asking, if acceleration due to gravity at height R from the surface of planet is 1 by 8 times that at a depth R by 2 from the surface. Depth R by 2 means the depth, what happened will indicate like this. This is a depth. Now at a depth here. So at point P2 is asking. Tell me who will contribute the field strength at point 2? Only due to the sphere of density rho naught, no? Because what about due to this? The field strength at this point will be only due to mass enclosed. You draw a Gaussian surface here. The field strength at this point will be only contributed by the mass enclosed. So what is the mass enclosed? Only M1. So but shall we write Z M1 R square? So what should be the formula? What is the field strength on the surface here? So how to calculate this one? I think I'm not bothered about outer part, no. Just only due to this. Only due to this, what is the formula? Gm1 by R2 whole square. But sir, you said we should use different formula. If if everywhere mass is present, you picked up that particular thing. So this point 2 is what? The point 2 lies on the surface of this sphere, no? And who will contribute the field at this point? Only this mass enclosed. Only this particular mass enclosed. Okay, so no need to do anything. Just it's like a only this much you have to take. Now it's asking the ratio of these two. Answer will come this. Check it. Huh? This is at a height. This is at a depth here. So when to use that formula, when height and depth is very much less than r, you have to use that formula. Otherwise, you have to stick on to the basic things. Okay, think on this one. You should bring your mathematics into picture.